Acha, in this lecture, we'll be doing question number 106 to 109. Okay, these questions are extremely important. So, although they might be little bit unintuitive to understand, just follow through these questions. Okay, they are extremely important for your curriculum and for conceptual grasp of the uh, chapters. Okay, so let's start with the first question, which is question number 106. See, in order to understand this problem, we must first understand the alternative question. Okay, so for example, I have a question out here. The question I have here is find the relation between velocity of a projectile and the angle of a projectile. Okay, so suppose this is a projectile motion. Out here it is projected with v naught at an angle theta naught. So at any point in this motion, it will be v theta. Okay, we do know horizontal component of velocity is constant. So v cos theta is equals to v naught cos theta naught. Okay, or v by v naught is equals to cos theta naught by cos theta. This is the relation, or I have found out. What have I found out here? I have found out the equation of velocity, or velocity as a function of theta. Cos theta by cos theta naught by cos theta. Okay. The problem is I'll do the same problem. Okay, but little bit in a twisted way. Twisted way means little bit in a lengthy way. How? So suppose this was the projectile motion. Okay. Why am I doing this in a twisted way? To understand the next problem I have in irodov. See, usually in projectile motion, what do? We component this velocity along x component, okay, and y component. But to find out the relation between velocity and theta, what we'll do out here is we'll component this velocity at instantaneous grid at each point. That means tangential to the velocity and perpendicular to the tangent, or centripetal to the velocity, or normal to the velocity. So at each point in the projectile, okay, our coordinate system would be, suppose I'm finding out the velocity out here, v, out here theta. My coordinate out here would be tangent to the projectile and perpendicular to the velocity. Okay, this is my coordinate system. My coordinate system is this one. At it at each point, this is nothing but the tangential component, and this is nothing but the centripetal component. Okay, and then what do? We add on the equation of motion. Okay, so suppose the velocity was going in v at certain instant with theta. Okay, so mg force would be acting downward. Okay, the component of mg force along the tangential component would be nothing but, if this is theta, okay, this entire angle is 90, so this angle is theta dash. Okay, and this line makes 90-degree angle. So if this is theta dash is nothing but 90 minus theta, so this angle would be nothing but theta. So this angle is theta. So if this angle is theta, then this line and this line is nothing but 90-degree. So if this angle is theta, this is nothing but 90 minus theta, or theta dash. Okay, so this component would be mg cos theta, and out here the component, tangential component, would be mg sin theta. So can I write the equation of motion as mg sin theta, okay, tangential component of force, is equals to mass into tangential acceleration. This is our equation number 1. Similarly, mg cos theta, or centripetal component of the force, okay, is equals to mass into centripetal acceleration. This is equation number 2. Okay, so out here, what is tangential acceleration? Velocity, or rate of change of velocity, dv by dt. What is centripetal acceleration? v square by r, or omega square r, or can be written as omega v. Okay, so for the purpose of finding out the relation between velocity and theta, we are finding out, or we are using omega v out here. Okay, so acceleration is equals to m omega v. Okay, and out here tangential acceleration is equals to dv by dt. dv by dt. Now if I cancel out the m, okay, so our equation becomes this one. Out here I cancel out the, okay. Now if I divide equation 1 divided by 2, equation 1 divided by 2, what do I get? If I divide this equation 1 divided by 2, okay, I get g and g would get cancelled. So tan theta would be equals to dv by dt divided by omega v, okay, or dv by dt into 1 by omega v. dv by dt into 1 by omega v. This is nothing but into. Okay, see, dv by dt divided by omega v is nothing but dv by dt into 1 by omega v. Out here we know that omega is equals to d theta by dt, d theta by dt. Okay, so out here if I rewrite this equation, it would be dt by this omega would get translated into d theta. Understood? How did I obtain this dt by d theta? Because omega is equals to, because omega is equals to d theta by dt. Angular velocity is nothing but rate of change of angular displacement. Now this dt and this dt would get cancelled. Okay, so out here if I cancel out this one, okay, our equation would be dv by v into d theta. See, I wrote this entire term out here, v into d theta. Okay, so now if I integrate this equation, okay, if I integrate this equation, I'll get the value of velocity as a function of theta. This was the equation that we formed. So tan theta into d theta is equals to dv by v. Okay, what is the integration of tan theta? Integration of tan theta is nothing but ln or log of sec theta. Ln sec theta is equals to ln v plus ln some constant. Okay, okay, so I can rewrite this as sec theta or ln sec theta. Ln sec theta is equals to ln v into some constant. Okay, whenever there is some log, just it is better to take the constant as ln of some constant, because out there you can directly multiply the constant. Okay, or if you do definite integral, you will get why I have taken ln constant. Okay, so sec theta, if you remove ln from both sides, is equals to v into some constant. Now if you apply boundary condition, what are the boundary condition? Okay, at theta is equals to theta naught, v is equals to v naught. So at theta is equals to theta naught, v is equals to v naught. So out here we have obtained sec theta naught is equals to v naught into constant, or constant is equals to sec theta naught by v naught. Okay, so if I rewrite this equation, v is equals to sec theta divided by, or constant. What is the value of constant? sec theta naught divided by v naught, which will go upward. So this is the same equation that I obtained before. The main purpose of doing this problem is to show you that in a projectile motion or in any motion, okay, in any curved motion, although you can do the component of velocity along vertical and horizontal component, you can also analyze the motion or instantaneous motion along a tangential component and a perpendicular component. Okay, perpendicular to the tangent component, or tangential component and centripetal component. That is the instantaneous analysis. Okay, in this question, what the question is saying is that a particle is projected with velocity v naught, okay, making an angle 90 degrees with the x-axis. Okay, and the friction force always acts opposite to the direction of relative motion. Okay, so write down friction force. Out here the particle experiences a friction force, no, and the direction of friction force will always be opposite to the direction of relative motion. So I'm writing this down. The direction of friction force is always opposite to the direction of relative motion. So what will happen? Initially the particle will try to move in this side, and slowly the particle will be parallel to x-axis. Why? Because there is a component of gravity force acting along this direction. Okay, so slowly this particle will be parallel to x-axis. Now the question is asking, as the particle becomes parallel to x-axis, find the total velocity or find the velocity as a function of phi, or find the velocity as a function of this angle. Okay, so initially when the particle was at this position, let me draw the free body diagram. So I'm looking at this particle from this position. Okay, so if I look at the particle from this position, the diagram would be somewhat like this. This is the inclined plane making an angle alpha, and out here our particle is there. Okay, the velocity of the particle is inside the plane of paper. Why? Because I'm looking from this side. Okay, so friction force, the direction of friction force would be outside the plane of paper. Okay, and there are two components of gravity, mg sin alpha and mg cos alpha. So the particle will try to accelerate along this direction, or along this direction and this direction. Okay, now after a long while, when the velocity of the particle became parallel to x-axis, okay, this is the initial diagram, initial motion. Okay, so after a long while, when this particle become parallel to x-axis, can I draw the free body diagram? So final motion of particle when this particle become parallel to x-axis. So when I draw the free body diagram, okay, that final moment, what will happen? This is the body. The velocity of the particle will be along this direction, no? See, as the particle moves and becomes parallel to x-axis, the velocity of the particle will be along this direction. So the velocity of the particle will be along this direction. So naturally the friction force would be along this direction, and there is a component of mg sin alpha out here and mg cos alpha out here, mg cos alpha, and there is a normal reaction force exerted by the plank on the block. Okay, now is the same concept as used in projectile motion to find out the relation between v and theta. Okay, so at any instant, say this is the instant when the velocity is making an angle phi with, suppose this velocity didn't start out here, suppose this velocity v naught started out here. Okay, out here this is the perpendicular line, and velocity started out here, v naught. Okay, and I'm taking a moment. Suppose this particle started out here, it came like this, and at any instant when the velocity was making an angle phi with this x-axis, okay, I'm trying to draw the component of forces. What are the two components? The instantaneous axis would be tangential axis, and centripetal axis. So this is nothing but the tangential axis. Tangential axis is always tangent to the velocity. Tangential axis and centripetal axis. Centripetal axis. Okay. Okay. So the job of this V naught is done. This was the initial. Initial means initially the velocity was V naught making an angle 90 degree with the x-axis. Okay. Now what is the direction of friction force? The direction of friction force is always opposite to the direction of velocity. Okay. In this direction, what force is there? In this direction, there is a force called mg sine alpha. Okay. So mg sine alpha acts along this direction. Sine alpha. Okay. So when you are studying this plane, okay, a component of mg sine alpha would act along the tangential component, and another component of mg sine alpha would act along the centripetal component. Okay, so let's draw the tangential component of forces. Tangential component of forces. Of forces. Okay, so if I draw out the tangential component of forces, what will it be? Equation: friction force minus mg sine alpha. The component of mg sine alpha along this line is nothing but mg sine alpha cos phi. So minus mg sine alpha cos phi is equals to mass into tangential acceleration. And which direction is the tangential acceleration? Along the direction of friction force. Why? Because out here, while the particle is moving, the magnitude of friction force is much greater than the magnitude of gravity forces along this line. Okay, so this is a tangential component of forces. Similarly, the centripetal component of forces is nothing but centripetal component of forces. Centripetal component of forces is nothing but, see, what is the only force acting along centripetal direction or perpendicular or 90 degree to this tangent direction? Is nothing but mg sine alpha cos, sorry, not cos, sine phi. See, if I take the component of this force along this line and this line makes a 90-degree angle. So if this is theta, this is nothing but 90 minus theta. So mg sine alpha into cos 90 minus theta. So it is nothing but mg sine alpha into sine phi is equals to mass into centripetal acceleration, and centripetal acceleration is always acting in this direction along the direction of radius of curvature. This much is understood. Now some of you might have doubt, sir, why am I not taking the component of these forces along this direction or this direction? See, I'm studying my entire motion in this plane, okay? So it doesn't matter whatever vector you take in this plane. Any component of mg cos alpha along this plane will always be 0. Why? Because any vector in this plane is always making 90 degree with mg cos alpha. Okay, so any vector of mg cos alpha along this plane is always 0. That is why I'm not taking it. Understood? Now we have obtained two equations out here. Okay, friction force minus mg sine alpha cos phi is equals to mass into tangential acceleration. So first you need to find out what is the value of friction force. The value of friction force is nothing but mu into n. And from the previous diagram, the value of n is nothing but mg cos alpha. Mg cos alpha. Okay, or is equals to mu mg cos alpha. What is the value of mu, of the coefficient of friction? The value of mu is nothing but tan alpha. See, coefficient of friction is given as tan alpha. So tan alpha into mg cos alpha. What is the value of tan alpha? Sin alpha by cos alpha. into mg into cos alpha. Okay, cos alpha and cos alpha would get cancelled. So the value of our friction force would come out as mg sin alpha. Sin alpha. Now notice one more thing. The value of friction force is mg sin alpha. So initially the velocity was in this direction. But once the velocity becomes parallel to x-axis, what is the driving force? This mg sin alpha or gravity force. What is the opposing force? Friction force. What is the value of friction force? Mg sin alpha. Why? Because coefficient of friction is equals to tan alpha. So when this particle becomes parallel to x-axis, will there be any acceleration? No, it will move with constant velocity. Why? Because driving force is mg sin alpha and opposing force, which is the friction force, is nothing but mg sin alpha. Understood? But till that happens, the body would try to change its direction in this along this direction. But any moment, okay, velocity v, and would apply the full value of friction force. Why? Because this body is already sliding. Okay, so out here, if I draw this equation or if I write this equation out here, okay, what would I get? The friction force, which is nothing but mg sin alpha minus mg sin alpha cos phi, sin alpha cos phi is equals to mass into tangential acceleration. What is the value of tangential acceleration? dv by dt. Okay, the value of tangential acceleration is nothing but dv by dt. dv by dt. Okay, similarly, if I use or if I take the centripetal component of forces, okay, centripetal component of forces is nothing but mg sin alpha sin phi, sin alpha sin phi is equals to mass into centripetal acceleration. And how can we write centripetal acceleration? Either omega square r or v square by r or omega v, which will suit us best. The value of omega v will suit us best out here. Okay, so mass into centripetal acceleration. I can also write omega as d theta by dt, no? Okay, so this entire term would be nothing but mv into d theta by t. mv into d theta by dt. Okay, now let's cancel out the mass term from this equation. This is our equation number 1. This is our equation number 2. Mass and mass gets cancelled. Mass and mass gets cancelled. So out here m and m will get cancelled. M and m will get cancelled. Now if I divide equation 1 divided by 2, okay, 1 divided by 2, what do I get? G sin alpha divided by G sin alpha sin phi is nothing but 1 by sin phi minus G sin alpha cos phi divided by G sin alpha sin phi. It is nothing but cos phi divided by sin phi. Okay, it is nothing but dv by dt divided by v d theta by dt. Now see, dt and dt would get cancelled. Okay, because I'm dividing it. Because I'm dividing this value by this value, can I write this value out here at the denominator? V d theta. Okay, okay. Or if I rewrite this equation, it is nothing but what is 1 by sin alpha? Cosec phi, sorry, 1 by sin phi is nothing but cosec phi minus cot phi is equals to dv by v d theta. Now we'll solve this equation on the next page. Okay, I have made a little bit of error out here. Out here I have written the angles in terms of phi, but out here I have differentiated in terms of d theta. See, rate of change of, see, in this curvature, okay, omega is nothing but rate of change of this angle. Okay, rate of change of this angle is only nothing but omega. Okay, so out here instead of d phi I'll write d theta, I'll write d phi or d phi out here, d phi out here. Okay, this term is a little bit difficult to integrate. Okay, so I'll just simplify this term. Cosec phi is nothing but 1 by sin phi, and cot phi is nothing but cos phi by sin phi. After this, I'm taking sin phi as denominator. Okay, and this becomes nothing but 1 minus cos phi. Okay, now there are very two simple trigonometric formulas. The first formula is sin a plus minus b, or sin a plus sin b, sin a minus b is nothing but sin a cos b plus minus cos a sin b. Okay, and the second is of cos a plus minus b is nothing but cos a cos b minus plus. Okay, that means when cos a minus b is given, cos a cos b minus sin a sin b minus sin a sin b. Okay, and when minus is given, cos a minus b cos a cos b plus sin a sin b. So the signs gets inverted out here. See, cos phi can be written as cos phi by 2 plus phi by 2. Okay, and if I apply this formula out here, okay, I'll get cos phi by 2 plus phi by 2 is nothing but cos square phi by 2 minus sin square phi by 2. Okay, and the second formula, if I apply sin phi, okay, sin phi can be written as sin phi by 2 plus sin phi by 2, phi by 2 plus phi by 2. So if I apply this formula out here, I'll get nothing but 2 sin phi by 2 cos phi by 2. Okay, so this is nothing but 1. Acha, see, and one more thing. Okay, 1 minus cos square phi by 2 minus sin square phi by 2. Okay, divided by 2 sin phi by 2 cos phi by 2. Okay, and one more thing, there is another trigonometric formula, cos square theta plus sin square theta is equals to 1. So I can rewrite as 1 or sin square theta is equals to 1 minus cos square theta. So similarly, if I put this thing out here, 1 minus cos square theta or 1 minus cos square phi by 2 is nothing but sin square phi by 2. Okay, see, if I rewrite this equation, I'm writing this equation down here, 1 minus cos square phi by 2 minus and minus becomes plus sin square phi by 2. Okay, divided by 2 sin phi by 2 cos phi by 2. The lengthy, this is mathematics, okay, this is nothing to do with physics. See out here, sin square phi by 2 is nothing but 1 minus cos square phi by 2. So 1 minus cos square phi by 2 is nothing but sin square phi by 2. So this is nothing but, if I erase this and make this sin square phi by 2, I can simply make this sin square phi by 2 and see out here. Sin square phi by 2 plus sin square phi by 2 is nothing but 2 sin square phi by 2. 2 sin square phi by 2. Okay, out here 2 and 2 get cancelled. Sin phi by 2 and square phi by 2 will get cancelled. So I'm cancelling out the 2 out here. I'm cancelling out sin phi by 2 and square out here. So sin phi by 2 and cos phi by 2 is nothing but tan phi by 2. Tan phi by 2. So this entire term is nothing but tan phi by 2. Or I can rewrite this term as tan phi by 2 is equals to
dv by v d phi. Okay, now I have to integrate this function. Okay, tan phi by 2 into d phi. I'm taking this d phi to the left hand side, is equals to dv by v, is equals to dv by v. The integration of tan phi by 2 is nothing but ln 2 to ln sec phi by 2. Okay, from acha is equals to ln v. Okay, integrating left hand side and right hand side. See, now we must put up initial and final condition. Initially it was making an angle, how much? Phi is equals to 90 degree. So initially this phi was 90 degree. And when this entire value becomes parallel, when this v becomes parallel, okay, it becomes 0 degree. But the question is not asking what is the velocity when the particle becomes parallel. The question is asking what is the velocity at midpoint when phi is equals to any particular angle phi. So outer final parameter is equals to pi. Similarly, when theta or when phi was equals to 90 degree, what is the initial velocity? The initial velocity was v naught, and we have to find out the velocity v out here. Okay, so out here, can I say 2 ln say 2 ln sec phi by 2 can be written as ln sec phi by 2 whole square. Okay, from phi to 90 is equals to ln v from v to v naught. This can be written as ln sec square phi by 2 minus ln sec square 90 degree divided by 2 is equals to ln v minus ln v naught, or ln sec square phi by 2 divided by sec square 90 divided by 2. 90 divided by 2 is nothing but 45 degree is equals to ln v by v naught. So if I remove ln from both sides, I'll get the equation sec square phi by 2 divided by sec square 45 is equals to v by v naught. Okay, okay. Now what is sec square 45? Sec square 45, sec square 45 is nothing but 1 by cos square 45. Okay, is equals to 1 by 1 root 2 whole square is nothing but 2. Okay, so sec square 45 is nothing but 2. So this is nothing but 2. Okay, and if I said, see, and sec square 5 by 2 is nothing but 1 by cos square 5 by 2. So nothing but cos square 5 by 2, 1 by cos square 5 by 2. I'm simply eliminating this from the top. Okay, and can I send this v naught to the left hand side? Obviously. So v is equals to v naught. So our main equation comes at v is equals to v naught by 2 cos square pi by 2. Now in the books, okay, in the solution books, the answer key is written in terms of cos 1 plus cos phi. That answer and this answer is same. Okay, see, let me erase this one. Okay, in your books, the answer is given in some terms of v is equals to v naught by 1 plus cos phi. See, all I'm saying is that this value, this answer and this answer is same. So I must say that 1 plus cos phi is nothing but 2 cos square phi by 2. So I'll just prove it out here. 1 plus cos phi, okay, is nothing but 1 plus cos square phi by 2 minus sin square phi by 2. Okay, cos a plus b or cos 5 by 2 plus 5 by 2. Just expanded this one. Okay, 1 minus sine square 5 by 2 is nothing but cos square 5 by 2. Why? Because sine square 5 by 2 plus cos square 5 by 2 is equals to 1. Cos sine square theta plus cos square theta is equals to 1. So 1 minus sine square 5 by 2 is nothing but cos square 5 by 2. So cos square 5 by 2 plus cos square 5 by 2, which is equals to 2 cos square 5 by 2. So this answer out here and this answer out here is same. So this answer out here and this answer out here is the same. Understood?
Acha. What this question is trying to say is that there is a circular sphere. Sphere is generally, if you see the sphere from any side view, it will appear a circle. On top of this sphere, a chain of length L is kept. Okay, a chain of length L is kept out here. Okay, let the mass of this chain be M. Acha. Out here there is a condition that L is lesser than 1 by 2 pi r. That means L, this length, should be lesser than the quarter of the circle. Why? Because this value pi r by 2 is nothing but the value of quarter of a circle or length of quarter of a circle. So what this equation is specifically telling us is that the length of the chain is lesser than quarter of the circle. Okay. Now the question is asking what will be the acceleration of each element of the chain when its upper end is released. That means when I release the hold from here, this chain will try to slip down. So what will be the acceleration of each of the element? So let us consider an elemental mass dm. Okay. Okay. So dm mass, substance d theta angle to the center. This is nothing but d theta. So this is nothing but theta. So for dm mass, what are the forces acting on it? For dm mass, what are the forces acting on it? The first force is mg, or gravity force. Okay, or dmg. The second force is normal force. Okay, and this elemental mass will have a tangential acceleration at, and of course there is a velocity along this direction, along the tangential direction in a curved path. So it will also have a centripetal acceleration ac. Centripetal acceleration ac. Okay, now see. Now can I write for tangential component? For tangential component. Okay. Acha. We need to figure out what is this much angle. See, acceleration or centripetal acceleration, that is normal, opposite to the normal, will always pass through radius. Why? Because perpendicular to any tangent in a circle always passes through the radius. So this line will always pass through the radius. Okay, this line will always pass through the radius. Okay, so an angle is making theta degree with the vertical. So if I say this angle is theta, that means this angle is theta. Okay, how much is this angle? This angle is also theta. Theta. Okay, and so this angle along the tangential direction, that angle would be theta dash, or 90 minus theta. So for tangential component, if I draw the equation of tangential component, can I write dm into g cos theta dash? Cos theta dash is nothing but cos 90 minus theta, which is equals to sin theta. Achha. Is there any other component of force along this line? No, only gravity force along this line is nothing but dmg sin theta is equals to dm into tangential acceleration. Okay, and for centripetal component, for centripetal component, okay, I think we don't need centripetal component for this question. See out here, tangential component. Now one thing to observe out here, the acceleration of each part of or each element of the chain would be same. The tangential acceleration or the magnitude of tangential acceleration for each element of the chain will be remain same, although the direction of tangential acceleration is different, but the magnitude of tangential acceleration for each part of the chain will remain same. Why? Because the chain is connected and has a constant length L. Okay, if this part has different acceleration, this will try to expand. See, if any part has different acceleration or different magnitude of acceleration than the other, then what will happen? That part will try to expand, or that part will try to separate from the group. So from the constant motion, every part of the chain will have same magnitude of tangential acceleration. So out here observe. Okay, every part of the chain, every part of the chain will have same magnitude of tangential acceleration. Fair and fine. So can I integrate this for the entire chain? This force was for what? This elemental strip. So I have to integrate this entire force for the elemental chain, for the entire chain. So similarly, I have to integrate out here also. Okay. Now the magnitude of this tangential acceleration is constant. So can I take this outside the integration? Or dmg sine theta is equals to at into dm. Okay. Acha. Can I write? Acha. Now how do I find out the elemental mass? See, before finding out elemental mass, let us discuss this one. Integration of mass, integration of elemental mass throughout the chain will give us the whole mass. So this is nothing but m. Okay. Now for the value of this dm. Okay. See, if the entire length is L, how much is this much length? Or how much is the element, or how much is the length of dm amount of mass? The length of dm amount of mass is nothing but r d theta. This length or this length is nothing but radius into angle subtended, or radius into d theta. So this much length is nothing but r d theta. Okay. So now can I apply unitary method? Unitary method means if 5 apples cost 10 rupees, 1 apple will cost 10 by 5. So 12 apple will cost 10 by 5 into 12. Similarly, if L length of chain contains m amount of mass, one length of chain will contain m by L amount of mass. So r d theta length of chain will contain m by L into r d theta amount of mass. And what is the mass contained in this dl, or what is the mass contained in this r d theta? Dm. So this is nothing but equals to dm. Okay. So can I substitute that value of dm by m by L r d theta sine theta? Okay, is equals to at into m. Now some of you might have question. So why didn't you write in terms of sine theta to the right hand side? See, even if I write sine theta in terms of sine theta in the right hand side, okay, sorry, not sine theta, d theta, okay, if I integrate that d theta, okay, the value of total mass will come out to be the same. There is no component of sine theta in the right hand side. See, I have nothing to integrate with d theta on the right hand side. So if I just integrate d theta from 0 to this length or this angle, I'll get the same value of mass. Okay, but on the left hand side I have to integrate d theta with sine theta, because there is an expression of sine theta on the left hand side. What this expression is telling is that at each component or at each part of the chain, the tangential and the centripetal component of gravity force will be a little bit different. For example, out here, the tangential component of gravity force is 0. For example, out here, the tangential component of gravity force is maximum out here. Understood? So you have to integrate sine theta with d theta out here. Okay, why? Because for the tangential component of gravity force is nothing but g of sine theta. Achha, I forgot to write the g. Okay, so out here take the constant outside, m by L r g sine theta d theta is equals to tangential acceleration into mass. Okay, what is the integration of sine theta d theta? Acha, can I cancel out the mass mm out here? Or Rg by L, I cancel out the mass, it would be Rg by L. Acha, what is the integration of sin theta d theta? Nothing but minus of cos theta is equals to Rg by L into minus of cos theta. Okay, is equals to tangential acceleration. Now I have to put the limits. Okay, from theta is equals to what to theta is equals to what. So if we start integrating out here, integrating with this element, out here theta is equals to 0. So theta is equals to 0. And we have to end our integration out here. So what is the value of theta out here? See, okay, this is a circular chain. Spherical, but if you see sphere from a 2D perspective, it appears as circular. This is L. Okay, this is the radius. This is R. Can I say L is equals to R into whatever this angle is? Let's say this is phi. Okay, this angle is phi. So can I say R into phi is equals to L? R into phi is equals to L. Okay, R into phi is equals to L. So phi is equals to L by R. So out here upper limits of integration is equals to L by R, or theta is equals to L by R. We have to integrate up till theta is equals to this much angle, this much angle. This much angle is nothing but L by R. Okay, so if I integrate this, one, or Rg by L is equals to minus cos L by R minus of, acha, minus of minus cos 0. Initial value is equals to tangential acceleration. Cos of 0 is nothing but 1. So Rg by L is equals to minus of cos L by R minus of minus 1. Okay, why? Because cos 0 is 1. See, minus of minus 1 will become plus 1, plus 1, and out here answer will come as a tangential acceleration is equals to Rg by L 1 minus cos L by R. Okay, in this question there is a sphere. Okay, the sphere is moving towards the left with velocity omega. Okay, this omega, this w. Okay, now on top of this sphere is a block of mass m. Okay, and this sphere is frictionless. So what will happen? This block will start sliding towards right. So after a certain amount of sliding, this block detached from the spherical surface. That means went off from the spherical surface. The question is asking, find the velocity of the block when this block detached from the spherical surface. And the second part of the question is asking, find the angle theta. Find the angle theta when this block detached from the spherical surface. So our main point of notion out here is, our main concept is, okay, when the blocks got separated, or when any two bodies get separated from the surface, the normal contact force is always equals to 0. So write down a note: during detachment, for any mechanics problem, during detachment, normal contact force is always equals to 0. Okay, so out here, if I draw the free body diagram of M out here, see, I must draw the free body diagram of this block from the frame of reference of this sphere. Why? Because it will be easier to compute. Okay, so if my frame of reference is the sphere, I'll get a pseudo force of m omega towards right and a gravity force acting in downward direction. Now my next question is, what should be the axis? See, if this body is sliding tangential to the sphere, the axis must always be tangential and centripetal axis. So there is a tangential axis which is making an velocity v. The tangential axis is making an velocity V. Okay, and the centripetal axis, this centripetal axis is nothing but this one axis. The centripetal axis for a spherical body or for a round body always passes through the center. Okay, this is a concept of mass. Okay, there is another force, normal contact force, which is always perpendicular to the surface of contact. Okay, and the value of normal contact force during detachment is equals to 0. So okay, let's write down the centripetal component of forces. Centripetal forces. Okay, Asha, we must find out this angle to take out the component along centripetal direction, no? So if I know this is a straight line, okay, this is a straight line, okay, this is a straight line. The angle between this line and this line is theta. The angle between this line and this line is theta. Okay, if I draw or if I elongate this mg line, okay, these two are parallel straight line. So if this angle is theta, this angle will also be theta. So this angle is also theta. See, now this line and this line are perpendicular to each other. Why? Because this is tangential, this is centripetal axis, and this angle is theta. So automatically this is 90 minus theta or theta dash. Now see, this line, okay, the downward line and the rightward line, this line is 90-degree angle, and this is 90 minus theta or theta dash. So automatically this will be theta. So this is theta. See again, this line and this line, okay, this line and this line makes 90-degree angle, and if this is theta, okay, if this is theta, this is nothing but 90 minus theta. Understood? So let's draw the centripetal, or let's write down the reaction and action forces. Mg cos theta, mg cos theta, or mg cos theta minus m omega, minus m omega cos theta dash, minus m omega cos theta dash. Okay, cos theta dash is nothing but cos 90 minus theta. Cos 90 minus theta is nothing but sin theta, minus n is equals to mass into centripetal acceleration. Now what is the centripetal acceleration? V square by r. Okay, what is the value of n? The value of n is equals to 0 during detachment. The value of n is equals to 0. So let's make this equation neat and clean. Okay, v square by r, v square by r. Let me write this equation close together. Okay, now the ideal thing to do would be write down the tangential component of equation, but we do not need the tangential component of equation, because in the tangential component of equation would have tangential acceleration, there would be no component of velocity. Okay, or there is no parameter of velocity in tangential component of equation right now. Okay, so one more easier thing to do would be apply work energy theorem. There is obviously component of tangential equation, but tangential equation is equals to v dv by ds, but that would be very lengthy. Okay, instead of doing that, I'm just applying work energy theorem. Work energy theorem. Okay, see, some of you have solved this equation using tangential component. Tangential component out here mass into tangential acceleration. No, substitute the tangential acceleration into v dv by ds. Okay, the thing you obtain is the same thing as work energy theorem. See, how is work energy theorem related to v dv by ds? See, can I say acceleration is equals to v dv by ds? Okay, just a v, or a ds is nothing but v dv. Okay, or out here a ds is nothing but v square by 2. Okay, now see, when you integrate you have to put a value of limits v final velocity, u initial velocity. So a ds is nothing but v square by 2 minus u square by 2. Okay, now there are two formulas that comes out here. V is equals to u square plus 2as. See, If you send the u square to the left hand side, this will come. Okay, this is the this for formula you learned in kinematics. And another thing is, if you apply m out here, m out here, and multiply m out here, okay, this becomes nothing but force. Okay, net force into ds is nothing but ds is equals to half m v final square minus half m v, sorry, v initial square or u square. F dot ds is nothing but total work done. So work done is equals to change in kinetic energy. So either you apply this or change in work energy theorem. Both are the same thing. The work energy theorem is derived from acceleration is equals to v dv by ds. So when I'm doing work energy theorem, no, I'm already writing the tangential component of equation out here. Understood? So out here, work energy theorem. Okay, but change in kinetic energy is equals to work done by all the forces. Out here, v is equals to 0 initial velocity and v final is equals to v. So can I apply half mv square minus 0 is equals to work done by gravity force. Acha, what is work done by gravity force? Gravity force into displacement. The displacement of gravity force is only this much. Okay, if I draw a line, is only this much. If I elongate this line, okay, this is the entire sphere, this is the radius, and this is another line. Okay, the work done by gravity is only this much. If this angle is theta, how much is this much length? See, this length is radius, this length is also radius. So can I say this much length is nothing but r cos theta? This much length is nothing but r cos theta. So this much length is nothing but r minus r cos theta. R minus r cos theta is nothing but this much length. So r minus r cos theta. This entire length is r. This much length is r cos theta. Similarly, how much is this much length? This much length is nothing but r sin theta. R sin theta. So half mv square minus 0 should be equals to work done by gravity force, which is equals to mg, okay, into r minus r cos theta, plus work done by pseudo force. Okay, see, some of you might have questioned, does pseudo force do some work? Pseudo force is a false force, no? Yes, because energy, okay, or work done or kinetic energy also depends upon frame of reference. Work done by a body or kinetic energy of a body or change in kinetic energy of a body also depends upon the frame of reference. Okay, so in this frame of reference, of course pseudo force is acting, so pseudo force will do some what? The work done by pseudo force is nothing but m omega into r sin theta, because the pseudo force did this much amount of work, into r sin theta. Okay, plus one more force is there, that is the normal force. The work done by normal force is always 0. Why? Because in normal contact forces, okay, during circular motion, any component of centripetal forces or work done by any component of centripetal forces is always equals to 0. Why? Because force is always perpendicular to displacement. Okay, that's why work done by any centripetal forces is always equals to 0. Any forces acting along this line will always be equals to 0, or work done by any forces acting along this line, okay, will always be equals to 0. Understood? So let me remodify this one, minus 0. This minus 0 is eliminated out here. So let me eliminate the minus 0. Okay, let me take the r common out here. I'm taking r common. Okay, so if I take r common, it would be this. Asha, if I take r common out here, it would be 1 minus cos theta. Okay, can I cancel m out here? M, M and M. If I cancel M, M out here, it would be nothing but half V square. Achha, can I bring this R down here? Of course, 2R, R. Okay, so my equation from molecular energy theorem becomes V square by 2R. So V square by 2R is equals to g into this one. So I got two equations. Okay, Acha, let me simplify this equation also. M gets cancelled. Okay, so this equation is from centripetal forces and this equation is nothing but work energy theorem. You can also make this equation from the tangential component of equation. Instead of tangential equation, write v dv by dx. Okay, now I'll solve these two equations on the next page. Acha, see, we have these two equations. Okay, and we need to find out two variables. The variables are, we need to find out the velocity and the value of theta from these two equations. Okay, so how do I do it? Let me just modify this equation a bit. V square by 2r, let me expand that one, g minus g cos theta, I'm expanding this term, okay, plus w sine theta. Okay, let me take minus common from here. Let me take minus common from these two. So if I take minus common from these two, what will happen? This positive sign will get converted to negative sign. Okay, now observe carefully. What is g cos theta minus w sine theta? G cos theta minus w sine theta is nothing but v square by r from equation 1. So this is nothing but v square by r, v square by r. So if I rewrite this equation, v square by 2r is equals to g minus v square by r. Okay, if I send this to the left hand side, v square by 2r plus v square by r is equals to g. If I take v square by r common, 1 by 2 plus 1 is nothing but 3 by 2. 3 by 2 v square by r is equals to g, or v square is equals to gr into 2 by 3. 2 by 3, or v is equals to under root of 2 gr by 3. Okay, so we find out the velocity when the body will leave the sphere. Okay, so at velocity is equals to 2 gr by 3 under root 2 gr by 3, the body will leave the sphere. Okay, notice one thing out here, the velocity at which the body will leave the sphere is independent of the acceleration of the sphere. See, there is no component of a out here. Understood? Now what do we need to do? We need to find out the value of theta. So to find out the value of theta, either substitute this value of v square out here or the value of v square out here. So I'm just taking this equation because this equation seems simple. G cos theta minus w sine theta is equals to v square by r. What is the value of v square? 2gr by 3. 2gr by 3. Okay, so out here if I write this properly, 2gr by 2gr by 3. Okay, now see, this r and this r would get cancelled, so it would be nothing but 2g by 3. Now see, let me just simplify this equation. Let's take 3 common. Okay, so 3g cos theta minus omega sine theta is equals to 2g by 3. So, sorry, I'm multiplying it by 3, is equals to 2g, not 2g by 3. I multiply this 3 to the left hand side. Okay. Now see, instead of writing g by omega, I need to find out the value of g by omega. I need to find out the value of theta. No, there are two variables, not two variables, two constant out here. G and W, both are constant. But in order to avoid confusion or in order to avoid cluttering up of my equation, I just take or I just divide the entire equation by g. Okay, divided by g, divided by g, divided by g. Okay, so it would become 3 cos theta 3 cos theta minus omega by g 3 sin theta is equals to 2. Now see, I can take or I can assume another variable n is equals to omega by g. Why am I doing this? To avoid the cluttering of this equation. Okay, so out here omega by g is replaced as 3 cos theta minus n or 3n sin theta minus 3n sin theta is equals to 2. Okay, now what do I do? See, it's better to either take in terms of cos theta or sin theta. Okay, either convert everything to cos theta or convert everything to sin theta by using the relation. Which relation? Sin square theta plus cos square theta is equals to 1. Cos square theta is equals to 1. So or 1 is equals to, let's say I'm converting everything to cos theta. So I must substitute this sin theta into cos theta. How do I do that? Cos theta or sin square theta is equals to 1 minus cos square theta, or sin theta is equals to under root of 1 minus cos theta. Okay, so let me rewrite this. Acha. Can I bring this 2 to the left hand side and 3 and this term to the right hand side? Of course. So it would become -2 plus 3n sin theta. 3n sin theta. Okay, I'm squaring both side. Squaring both left hand side and right hand side. What would I get? 9 cos square theta, then plus 4 minus 2ab. 3 2 is 6, 6 2 is 12. 12 cos theta is equals to 9n square sin square theta. Okay, or out here. Okay, let me put this sin square theta into 1 minus cos square theta, or 9 cos square theta minus 12 cos theta plus 4 is equals to, I just wrote this out here, and 4 to the right hand side is equals to 9n square. And what is sin square theta? Sin square theta is nothing but 1 minus cos square theta. 1 minus cos square theta. Okay, now what do I do? So I expand this 9n square minus 9n square cos theta, or 9 cos square theta. Let me just solve this equation. Then I bring the entire term to the left hand side. I bring this entire term to the left hand side. So I get this equation. I get this equation. Now from this equation, okay, I'll just organize cos square theta, and term without any cos. Okay, why I'm making this into a quadratic term? So let me erase these 3 lines. Okay, I'm erasing these 3 lines. Now out here, if I term up all the cos square theta, but if I rearrange this entire thing, okay, first by cos square theta, then by cos theta, and last by any terms without cos theta, what will I get? I'll get this term. Okay, I'll get this term, this entire term. Let me take 9, or let me take cos square theta common out here. So if I take cos square theta common out here, my entire equation will be this one. Now this equation is a quadratic equation in terms of cos theta, okay, which I'll solve in the next page. Now this thing is a quadratic equation in terms of ax square plus bx plus c. Okay, out here x is equals to cos theta, a out here is equals to 9 plus 9n square. Okay, b is equals to minus 12, and c is equals to 4 minus 9n square. Okay. What are the roots of quadratic equation? The roots of quadratic equation are nothing but x is equals to minus b plus minus b square minus 4ac by 2a. Okay, out here, if I substitute the value of b by this one, a by this one, and c by this one, what will I get? And x by cos theta. So I can write, so cos theta is equals to this term after substitution. Now if I look at only this term, I'll first simplify only this term. Okay, out here. So when we expand this term, no, what happens? We get to this term, and when we calculate this entire term, we get nothing but a simplified term of 180 n square plus 324 n to the power 4. So out here cos theta is equals to minus of minus 12 plus minus how much? 180 n square plus 324 n to the power 4. Okay, divided by 2 into 9 plus 9n square. Now let me expand the denominator. So 9 to the 18, it will be nothing but 18, 9 to the 18 plus 18 n square. I'm just expanding this denominator out here. This denominator out here. So let me erase this one. Now see out here. If I take 36 common out here, okay, or cos theta is equals to 12 plus minus root over 36 n square. I'm taking common out here. Okay, this is nothing but 5 plus 9 n square. Okay, divided by 18 plus 18 n square. Now if I take this 36 n square outside the square, it will become 6n. So out here it would become cos theta is equals to 12 plus minus 6n, how much, divided by 5 plus 9n square, 5 plus 9n square, divided by 18 plus 18n square. Now if I divide numerator and denominator by 6, what will I get? Cos theta is equals to 2 plus minus n 5 plus 9n square divided by how much? 3 plus 3n square. But if I take 3 common out here, I'll get 3 into 1 plus n square. 3 into 1 plus n square. Okay. So this is the value that I. Now out here n was nothing but a by g. Okay. And the question, sorry, not a by g, w by g. But the acceleration in irodov is taken as w. Okay. Now second part of the question is what happens when the acceleration is equals to acceleration due to gravity? The value of n becomes 1. So out here this value of n becomes 1. So I put the value of n is equals to 1. Find out the value of cos theta. So when n is equals to 1, or when acceleration of the sphere in the left hand direction is equals to acceleration due to gravity, when n is equals to 1, what do I get? Cos theta is equals to 2 plus minus 1 into 5 plus 9. 5 plus 9 is 14 divided by 3 into 1 plus 1 square, 2. 3 into 2 is nothing but 6, or 6 out here. Okay, so out here it's nothing but, if I assume this value, okay, see, I cannot take minus out here because 2 minus root over 14. Root over 14 is much greater than 2. Okay, so assuming the positive value out here, cos theta would be equals to, when I use calculator, I got cos theta is equals to 0.956, or theta is equals to cos inverse 0.956. The value of theta becomes nearly 16.87. I used calculator for this. Okay, you cannot do this by hand. This question uses the concept of circular motion. Okay, so suppose in a circular orbit, a particle is traveling in a circular orbit. Okay, for this particle to travel in a circular orbit with constant velocity v, okay, it will only travel in a circular orbit if there is a centripetal force. Why? Because the force is required to change the direction of the particle in a circular orbit. Okay, now what happens if this velocity, or sorry, not velocity, what happens if this force is very weak compared to the velocity? Okay, if the force is very weak, or the centripetal force is very weak, what will happen? The particle will stray outside. Okay, the particle will try to make a larger circle or go stray outside. Okay, now the question is asking, given centripetal force is equals to 1 by r to the power n, where r is the radius of the circular orbit. for what value of n the particle, if the particle goes outside the orbit, okay, the centrifugal force also increases, so that the particle tries to come back to its circular orbit. That means the particle will be in a stable orbit. Stable orbit means, suppose for a constant velocity, if this force, okay, suppose r 1 by r to the power n, some value of r to the power n, okay, suppose r is equals to 2. If the particle goes outside, what will happen? R will increase, so r to the power 2 will increase, but 1 by r to the power 2 will decrease, so the force will decrease. So as the particle goes outside, the force decreases, okay, and as the force decreases, the particle will go more outside. So for what value of n, when the particle goes outside, the force will get stronger and bring the particle to its circular orbit? That is my main question. Okay, so out here, can I write 1 by r to the power n, or centrifugal force, is equals to mv square by r? Instead of making 1, let's make it a constant, a by r to the power n. Why? Because out here it is saying the particle depends, see, on a distance, the velocity, and depends on the distance to a certain point on a plane y 1 to the power n. Okay, so f is directly proportional to, f is directly proportional to 1 by r to the power n, and when we remove the proportionality, we get a constant of a. Okay, now what happens if we increase the radius by delta r? So I can simply say, when you reduce the delta r, r plus delta r to the power n, okay, should be greater than equals to mv square by r plus delta r. Okay, why? Because when the particle goes outside, as long as this force is greater than this force, then only the particle will try to turn back in its circular orbit. No, understood? Because as the particle ventures out, the centripetal force must be stronger compared to the velocity it is moving. Okay, so this much is understood. Now the remaining part is simple. What is the value of a out here? We substitute the value of a out here from this equation into this equation. So out here, a is equals to r to the power n minus 1 into mv square. Okay, okay, now substitute this n out here, sorry, a out here. If this a is substituted out here, we get r to the power n minus 1 mv square by r plus delta r to the power n is greater than equals to mv square by r plus delta r. Okay, mv square gets cancelled. Now see, if I bring this parameter up here, what will happen? R to the power n minus 1 into r plus delta r divided by r plus delta r to the power n should be greater than equals to 1. Okay, if I bring this to the down, if I bring this to the down, it will happen n minus 1, the entire parameter, this entire parameter, when it comes down, it will become n minus 1. Okay, simple exponents. Okay, now what to do? Now let's take r common from denominator. R to the power n minus 1, I'm taking r common from denominator. R to the power n minus 1, 1 plus delta r by r, a to the power n minus 1 should be greater than equals to 1. These r would get cancelled. Okay, these are got cancelled. Okay, and this is nothing but 1 by. Okay, now see, from binomial expansion. Achha, before binomial expansion, we already know that if 1 by something should be greater than 1, then 1 plus r plus delta r by n to the power minus 1 should be lesser than 1. See, if 1 by 2 is greater than 1 by 3, that means when you invert is 2 is lesser than 3, no? The similar concept we apply out here. So 1 plus delta r by r to the power n minus 1 should be lesser than equals to 1. Okay, now from binomial expansion, 1 plus x to the power n minus 1 is nothing but 1 plus n minus 1 into delta r by r into delta r by r is lesser than equals to 1. Okay, 1 and 1 got cancelled, or what do we get? If I cancel 1 and 1, I get 0. Okay, or n into delta r by r minus delta r by r is lesser than 0. Okay, see, if I take common out here, delta r by r, delta r by r, I'm taking common out here, n minus 1 is lesser than 0. Okay, so the only root of n is nothing but n is lesser than equals to 1. See, if I solve this one, okay, delta r by r is not equals to 0, it's somewhat very small but not equals to 0. Okay, so n minus 1 should be lesser than 0. So the solution of this is nothing but Asha. If you want to go with mathematics, either delta r by r should be lesser than equals to 0, or n minus 1 should be lesser than equals to 0. Okay, the coefficient being asked is the coefficient of n. What is the value of n? So we must focus on this solution. So when n is lesser than equals to 1, when n is lesser than equals to 1, then what will happen? The force will, or the centripetal force will be in a stable orbit. That means as the velocity increases, the centripetal force increases much greater than the required value to bring that into a stable orbit. Understood? Because that's it.